Hello, welcome all to the US Study Buddy. Today we are going to discuss about a topic line and plane in the 12th class question bank series. So let us understand few basic before we proceed. Line. Equation of line passing through a given point and parallel to the given vector is given by r vector is equal to a vector plus lambda b vector, where line is passing through the point A with the position vector small vector and it is parallel to the B vector. The Cartesian equation of the line passing through the point A, x1, y1, z1 and having direction ratios small a, b, c is given by x minus x1 upon a equal to y minus y1 upon b equal to z minus z1 upon c. Equation of line passing through 2 points will be given by r vector is equal to a vector plus lambda into bracket b vector minus a vector. Distance of a point from a line. The distance of a point P alpha from the line r vector equal to a plus lambda b is given by distance is equal to square root of alpha minus a bar the whole square mod of alpha minus a bar the whole square minus alpha minus a bar dot b vector upon magnitude of b vector the whole square. Distance between skew lines. The distance between the skew lines is given by a2 minus a1 multiplied by b1 cross b2 upon mod of b1 cross b2. Question 1. Find the point on the line x1 plus 1 upon 2 plus y plus 2 upon 3 equals to z minus 3 upon 2. So you have been given the Cartesian equation of the line which is at a distance of 5 units from the point 3, 1, 3. So you need to find a point on the line for which the distance is 5 units. We have been given that A is a point which is at the distance of 5 units from the point P which is on the line, and we need to work out what are the coordinate of x, y, z. Okay. So let us assume this is the equation of line given in the coordinate form, right? So it is x plus 1. This is the equation of line. I am just rewriting it. Z minus 3 upon 2. Let me call it is equal to 2. So I'll be getting the value of x is equal to, it will be 2k minus 1, y equal to 3k minus 2 and z is equal to 2k plus 3. What we need to work out? We need to find out what is length AP or distance AP by working out this distance. And we can equate, because this is given, this distance is given to a 5, if we can equate and then we can evaluate the value of k. So, before proceeding further, we need to evaluate what is the vector AP. So, vector AP, as you can guess, it is p vector minus a vector. So, p vector minus a vector will be, so these are the points. These are the p vector points. So, x, y, z, these are the coordinate of p and they are 2k minus 1, 3k minus 2, 2k plus 3. So, here, p minus a will be 2k minus 1 minus 3 into I, 3k minus 2 minus 1 into j plus 2k plus 3 minus 3 into k. So when I work out, it is 2k minus 4 into I plus 2k minus 3 into j plus 2k plus 0, that is 2k. That is what are the coordinates for the vector AP we are getting, and we know that magnitude of vector is nothing but the square root of all these components of I, j, k. So it is 2k minus 4 square plus 3k minus 3 square plus 2k square. So it will be 4k square minus 16k plus 16 plus 9k square minus 18k plus 9 plus 4k square. And this length or distance is going to be 5. So this will be 5 and this whole term is under the square root sign. So when I evaluate, what I will be getting inside the square root sign, it gives me 17k square minus 34k plus 25. And when I square both the side, this square root sign will be removed and I will be getting 25 here. So what is the value of k that I can figure out? It is k 17k square is equal to 34k. That is 17 2 k square minus 2k equal to 0 implies k into k minus 2 equal to 0. K is 0 or k will be equal to 2. So in order to get the coordinate for k, coordinate of p, we need to substitute the value of k in this, right, in star. So the point will be when k is equal to 0. When k will be 0, the point will be minus 1, minus 2 plus 3. And when k is equal to 2, we get a point 3, 4 and 7. So this is how you are going to work out the coordinate for the point P. Question 2. Find the length of a perpendicular drawn from the point P 3 to 1 to the line r vector is equal to 7i plus 7j plus 6k plus lambda minus 2i plus 2j plus 3k. So we need to calculate the length of a perpendicular, that is the distance of a point from the line. So same formula we can use to solve this problem. The second problem. Here we have to find out what is the distance, perpendicular distance of a point from a line. And we have been given the vector notation of a line. So what is given to us is a vector equation of line. So vector equation of line is given as r vector is equal to 7i plus 7j plus 6k plus lambda into minus 2i plus 2j plus 3k. So if you can compare with the standard form of vector equation, it is a vector plus lambda b, giving me the value of a vector will be 7i plus 7j plus 6k. B vector is 2i plus 2j plus 3k. And we know that the formula that we used to find out the perpendicular distance of a point to the line is given by alpha vector minus a vector. Here alpha is a point, right? So here alpha vector will be the coordinate of point P, that is 3i plus 2j plus 1k. Now the formula says we have to get the term of alpha minus a vector. So alpha minus a vector will be 3i minus 7i, giving you minus 4i minus 5j minus 5k. We need to get the mod of this alpha minus a vector. So it will be square root of 4 square is 16 plus 25 plus 25, giving you under root of 50 plus 16, that is 66. Now let us evaluate the value of alpha minus a vector dot b vector, which is equal to alpha minus a vector is this my vector that I have just evaluated. So it is minus 4i minus 5j minus 5k dot. Vector of b vector is minus 2i plus 2j plus 3k. So it will be a1 into a2, b1 into b2, c1 into c2. So we will be getting 8 minus 10 minus 15, and that is equal to minus 70. Now one more term that we need to get is mod of b vector. So it is nothing but square of all these coefficients, that is 4 plus 4 plus 9, again giving you root of 70. So substituting all the values that we have just now evaluated in star. So star implies distance is equal to square root of alpha minus a vector the whole square, that is root of 66 square, that is 66, minus dot product, it is equal to minus 17, upon root 17 the whole square. So here root 17 remains and square of negative 17 will be plus 17. So it is 66 minus 17 giving you root of 49. That is equal to 7 units is the answer. So this is how you. Question number 3. A line passes through 3 minus 1 2 and is perpendicular to the line. So there are two lines to which the given line is perpendicular. Equation of first line is r vector I plus j minus k plus lambda 2i minus 2j plus k, and second line is r vector equal to 2i plus j minus 3k plus mu into I minus 2j plus 2k. Find its equation. In this problem, we have to find out the equation of a line for which these two lines are perpendicular and it is passing from the point 3 minus 1 2. So we have been given these two equations in vector form and we have been told that both are perpendicular to the given line. So therefore the vectors along the given line will be this B vector part. Let me call it as A vector. From the first we get 2i minus 2j plus k, and from the second equation we get the perpendicular vector is I minus 2j plus 2k. So for the required line, the vector which is perpendicular to the required line will be A cross B, and that will be obtained by I, j, k. It is 2 minus 2, 1, 1 minus 2, 2. That is equal to I minus 4 plus 2 minus j into 4 minus 1 plus k into minus 4 plus 2. It is equal to minus 2i plus 3j minus 2k. Minus 2i plus 3j minus 3j minus 2k. And now the required line is passing. So therefore the line passing through (3 minus 1 2) and perpendicular to 1 is given by, in vector notation, vector equation of line will be r vector, and this will be my A vector, so it will be 3i minus j plus 2k plus lambda into, this is my perpendicular vector, so lambda into minus 2i minus 3j minus 2k. So that is what is the answer. Exercise. Find the vector equation of a line passing through the point having position vectors 2i plus j minus 3k and perpendicular to the vectors I plus j plus k and I plus 2j minus k. So you need to work out the equation, vector equation of a line, and secondly show that the line r vector equal to minus I plus 3j plus 4k plus lambda into minus 10i minus j plus k and r vector equal to minus 10i minus j plus k plus mu into minus I plus 3j plus 4k, they intersect each other. So solve this exercise, find the solution, do write the comment about the answers that you have opted. See you very soon with the interesting topic. We will continue with the planes in the part 2 of line and planes in the next video lecture. So see you very soon. Thank you.